Thank you for joining us in re:Invent, and also thank you very much for joining our session today, which is Layered Perimeter Protection on Applications Running on AWS. My name is Woodrow Arrington. I'm a Senior Product Manager on Amazon CloudFront. I'm also co-presenting this session with Ritwik Menon, who is also a Senior Product Manager on AWS Shield. Now, today's session is being recorded and will be available on YouTube for your own reviewing or to share the session with someone else who you think would also be interested to learn a little bit more about this topic. But also, the deck will also be available on SlideShare so that you can also look at the references and the links and look at the content from there. Now, today's session is an introduction into the security that is provided by many of the services on AWS and how you can secure and protect your applications running within the AWS environment. We're going to talk about the different layers of perimeter protection and how you can set that up around your AWS architecture. And we're going to show you how those layers can be automated for low maintenance going forward as well. We're also going to demonstrate a couple of these security features, and despite their simplicity, they have pronounced impact on the security stance that your applications will take. And lastly, we're going to show you a few other AWS configurations that might be a little bit more representative of your own applications to try and show a breadth of AWS configurations and how each one can be configured and protected with just as much security as what we are presenting throughout the session. Now, many of you have several applications, and each of these applications are becoming increasingly complex. There are more and more endpoints to manage and a whole host of different types of content flowing through your applications. Now, with this complexity comes different challenges, making sure that everything is properly secured. A survey that was conducted a few months ago by identity and access management company LogMeIn had revealed some very surprising statistics. The first was that a third of IT professionals did not know how many endpoints they were actually managing. Another statistic showed that a half of those professionals were also not taking proactive measures to address the security concerns that they had. And these were very surprising and things that you wouldn't normally think would be out there in our field. But the reality of needing to protect our applications on all fronts is ever present. And we know this because there are always malicious actors out there probing our applications for vulnerabilities. They're looking for exposed targets. Now, the mentality of hiding in the herd of millions of other applications or websites and hoping that you're not in the crosshairs of that next hacker is not a reliable security policy that you can present to anyone within your organization. So how do we address this? Well, first let's look at the attacks or the threats that are coming at us from multiple vectors. There are first DDoS attacks that are out there to try and exhaust our resources so that it will no longer be available to legitimate user traffic trying to access your application. Now, this includes volumetric attacks, transport layer attacks, and application layer attacks as well. Now, within DDoS, we're seeing two main trends. I'm not diving deep into this, but just a high level. The first is that short-lived DDoS attacks that last only a minute or so are increasing in frequency. The second is that the larger DDoS attacks are growing exponentially in size. An example of this is the memcached attack that we had seen earlier this year, which is more than twice the size of the previous record, which was held by the Mirai botnet attacks. Now, the memcached itself had peaked well over 1 terabyte per second, so it's quite large. And in addition to DDoS, we're also confronted by web application attacks and exploits where they're looking for some type of weakness in our application code. And then lastly, there are the bots. There's all kinds of bots, some good, some bad. But bots in general are generating probably about half of all web traffic out there. The good ones are good for SEO, site indexing. The bad ones are out there trying to scrape your sites and steal your content. So we always know, and we can never underestimate or underemphasize the statement that security is and will always be the absolute #1 priority. But the important part to think about this is that security is not a one-time operation. It is a process of evolution, trying to evolve just as frequently or fast or faster than the threats that we're exposed to out in the market or in the wild. Now, another surprising statistic that came from that same survey that I had referenced earlier had stated that a quarter of those surveyed were not taking automated measures to automate their monitoring and security alerts. Now today we're going to address those concerns that were identified by the survey. We're going to consolidate as many endpoints as we can through a single front door for your application so you know where that front door is, thus reducing any exploits that might be coming from unknown vectors. We're also going to create a proactive security policy and also show you how you can automate your security in certain ways to help it evolve with time. Now, by the end of this session, we'll have hoped to have achieved our objective, which is to build a highly scalable, secure, well-monitored, DDoS-protected application. It's a mouthful. But together, we're going to do this by a few key principles. The first being is that we're going to secure your content delivery through Amazon CloudFront. And we're going to do this whenever we possibly can. This will be the front door for your application. We're also going to set up a web application firewall to prevent certain exploits, such as the cross-site scripting or SQL injection. And lastly, we're going to review how you can protect yourselves through DDoS mitigation techniques with AWS Shield and AWS Shield Advanced. Now, throughout the presentation, as I referenced back, there's the automation of it that is important. And we're going to show you how, through each of these different principles and layers, there are different things that you can do to automate that security so that your application is, again, evolving with time. Now, throughout the session, we're going to show you visually how each of these layers are being added to a basic web application. Now, here we're just showing a very basic web application, and we know that this is not representative of everyone's application, but we present it to show the principles of where these security layers are being added and to demonstrate, again, what we are talking about today. Now, let's begin by first talking about that first layer of perimeter protection, creating that front door by using Amazon CloudFront whenever we possibly can. Now, Amazon CloudFront is AWS's content delivery network, also known as a CDN. Now, CloudFront is great at content acceleration, and many of you use it to improve the performance of your application. But it's also important to remember or think about CloudFront as a security product in and of itself. Now, CloudFront is unique against any other CDN that you could possibly choose in the market because CloudFront is tightly integrated within the AWS environment. With CloudFront, you can define where that front door of your application is going to be and use our AWS integrations to build that comprehensive security policy around that front door. And it is a central point in which you can bring in the AWS services such as AWS WAF, AWS Shield, and AWS Certificate Manager as well. These three things put together with CloudFront will give you that comprehensive protection that we're all seeking and that we all need. Now, using CloudFront is also going to give you the benefits of mass scalability, and it's also going to help you through that mass scalability to absorb those DDoS attacks and disperse them across the global network. This will allow you to maintain your ability to serve legitimate traffic so that your application is always highly available. Let's talk a little bit more about that mass scalability. The mass scalability of CloudFront begins with its global network of 150 edge locations worldwide. The large global network that we have helps protect against the DDoS attacks by dispersing that traffic across our edge locations and shielding your application from direct attack, but also shielding your application from direct user access as well. We'll get into that in the next slide, or in 2 slides. But each CloudFront location is built with multiple internet transit connections and links, as well as being directly connected to the AWS private backbone network. What this does, it means that we have massive capacity to absorb the bad traffic that comes our way, while again maintaining the ability to serve your legitimate traffic. But another point of infrastructure and application security is, again, sometimes overlooked, is the infrastructure security that your application is running on. But by using CloudFront's network, you can have the peace of mind that each of our edge locations is built to an incredibly high standard of security measurements and robust security measures that AWS mandates across all of our infrastructure builds. What this means is that because of these robust security measures that we take, we meet or exceed requirements for a wide range of compliance standards. And this includes things such as PCI DSS, HIPAA, SOC levels 1, 2, and 3, GDPR, as well as ISO standards But it's important to note here that when we talk about these compliance standards, we don't put out any caveats in terms of, well, we are compliant if something, as other CDNs do. It's important to note that, again, with CloudFront, we fulfilled those compliance standards. Now, getting back to how our infrastructure is built, it's important to look at this because the two architectural layers that we have shield your origin from direct user access and direct attack. Each user request that comes in will first begin by resolving to a local CloudFront edge location, and that is based on the lowest latency algorithms, so it's the best and fastest user experience for the end user. Now, content that is found within that local edge cache will be immediately served back to that user, while any miss will first check our second tier or mid-tier cache, which has larger cache width, so that is a higher likelihood that we'll have a cache hit. In the event that anything is not found in that tier, we'll then interact with your origin to fetch that content to reply back to the user request. Now, you can use CloudFront to secure and accelerate a whole range of content types, so essentially being able to secure and accelerate your whole application. And the latency reductions that you will receive by using CloudFront as your endpoint are substantial. Now, let's first talk about static content, because static content is central to each and one of our applications, or at least most applications. This is going to include things such as JavaScript, HTML, and images. But it can also include video on demand content, such as pre-recorded content, as well as live streaming content as well. And this is particularly beneficial when you're using AWS's integration, or CloudFront's integration, with AWS Elemental Media Services. Now, over the past few years, we've served and delivered a wide number of large-scale live streaming events, such as the 2018 Winter Olympics, Thursday Night Football through Prime Video, and also the 2018 World FIFA Cup. But CloudFront is more important than just the static and the video aspect. It's also very important when it comes to securing and accelerating dynamic content as well. And this includes things such as APIs or user inputted information for operations such as puts and posts. And when we have a lot of great use cases and videos and case studies that talk about all the different ways many of our customers are using CloudFront in this capacity on our website. And I'd invite you to go ahead and look at that for an example that might speak to you a little bit more personally. But what I do want to draw attention to today is another type of dynamic content that we now recently announced support for. And this comes in the form of the WebSocket protocol. Last week, we had announced the support for this WebSocket protocol, which is used for bidirectional and real-time communication between client and server. Now, this is commonly used for real-time applications such as chat applications, online collaboration platforms, or financial trading platforms as well. And customers that have been able to preview this new feature have been very pleased with their ability to consolidate more of their applications' endpoints behind the security of CloudFront. And this is the security that we're going to dive into a little bit more deeply here. But just in short summary, Coins.ph, which is a cryptocurrency or digital wallet platform in the Philippines, and Evolution Gaming, which is for live casino experiences, they both use CloudFront to great effect to be able to simplify their architecture, again, by reducing the number of endpoints now all going through CloudFront. So now let's turn more towards the aspect of what we're here today, which is the security portion. Now, much of the security that CloudFront provides comes through the means of the SSL and TLS protocol. As you can see by the chart, each year more and more CloudFronts are choosing to leverage CloudFront to encrypt more and more of their traffic. So how does CloudFront make it easier for you to adopt the TLS and SSL protocol and receive the security benefits that you need? First of all, the global network that CloudFront uses supports both HTTP and HTTPS content on the same network. This means that you don't have to manage two separate networks to just get security content for those that are able to communicate over that SSL protocol. But it also means that you can do anything unencrypted if that's something that works for the types of clients or browsers that you have on the client side. Now, we perform a lot of SSL optimizations behind the scenes on your behalf. This includes things such as strict enforcement of any security protocol that you put in place, such as a TLS policy, of which we will always opt to use the strongest suite of ciphers that you've chosen within that policy. The optimizations also extend into things like perfect forward secrecy, which, if I give a short summary, allows you to protect every individual user session because we're generating unique keys for each session, so that any compromise of the session key is isolated to that single user event right then and there. And it does not allow a man in the middle to use those keys to decrypt any other session that might be flowing between the client and the server. The other optimizations that I'd like to call out would be something like OCSP stapling, which is going to shift the heavy load of validating digital certificates from the client to CloudFront being able to act on the behalf of your client and origin interaction and validate those certificates and reuse it whenever possible. We've made it easy for you to receive these security benefits by giving you many different options to get started with the SSL and TLS within your CloudFront distribution. First and foremost, you can use CloudFront's default SSL certificate, which is free of charge and requires minimal effort on your part to get started. Now, if you want a custom SSL domain, we support both the SNI or the server name indication extension, as well as SSL certificates being served over dedicated IP addresses. Now, here you can either bring your own certificate and upload it into ACM or AWS Certificate Manager, or you can easily get started by using AWS Certificate Manager to get your own new certificate. And if you use that feature of getting your own certificate through AWS ACM, you can actually get it for free if you're going to use it within the environment of the AWS's ecosystem. So in this case, if you attach it to your CloudFront distribution, it's going to come free of charge. And it's very easy to go ahead and make that request, validate your request, and attach it to your CloudFront distribution all within a couple of minutes. Another important aspect of this is that ACM will go ahead and manage the renewal of that certificate each year on your behalf if that's what you want to configure. Now, using SSL allows us to get that end-to-end encryption between the client and the origin. But what about applications that handle sensitive user information that require even more security than just that end-to-end encryption? And that's where field level encryption comes into play. It actually allows you to restrict internal access to your content. Now, why would you want to restrict internal access to some of the information coming into your origin? This comes from the standpoint of wanting to have even more granular control over specific form field data that can only be accessed by certain subsystems within your origin. Now, for example, we had done this because customers who process payment information in like retail environments, and they have that credit card information of all their different users transacting across their site, they wanted to encrypt that information so that no other back-end subsystem would be able to access that information except for the payment processor. And what this did is it allows you to encrypt those fields like the credit card information so that it helps mitigate exposure of that sensitive customer information. And it also helps prevent it from being accidentally logged in a clear text form or being exposed through some type of core dump. If you want to learn more about this feature and the benefits that it delivers, we have a whole webinar that has already been recorded and is live on our website, where you can dive into not only what this feature does, but how to implement it and do it step by step. Now, aside from internally restricting access to your content, sometimes you want to restrict content to your restrict access to your content externally. And you can do this in a number of different ways. You can do this for a specific period of time or to certain users, either by geography or maybe some type of header information or some type of cookie. You can do this by using signed URLs, signed cookies, or geo-restriction. And each option provides you with immense configurability to control how your content is being accessed, as well as how your URLs are being managed in that interaction. I'm not going to dive deep into these concepts, but the basic idea is that you're going to sign the URL with a private key that you have. and you're going to give CloudFront the public key, of which it can then use to decrypt that signature and compare it against the policy that you've established. And if it's valid, we'll go ahead and serve the content. If we look at geo-restriction, it's about as easy as it sounds. You're either going to create a whitelist or a blacklist of countries that you want to either serve or block content from. Now, no matter how secure you make CloudFront or your front door, if your origin is still directly accessible from the public internet, all of these security measures that you're taking sometimes might be rendered completely ineffective. This is where it becomes vitally important to reduce the surface area of your application and make it only accessible through a known path. This being the known path being your front door through Amazon CloudFront. And we can do this in multiple ways. If you have S3 buckets, you can protect this through a feature called Origin Access Identity. Or if you have any type of custom origin, such as an EC2 instance or an application load balancer, you can do this through security groups and using the CloudFront IP ranges to restrict access to requests only coming within those CIDR blocks. Now, I'm going to go ahead and switch over to a demo to just quickly show how easy it is to get started with Origin Access Identity, and then we'll talk about how you can do this for custom origins as well. All right, so here I am logged into the AWS console. I've already gone ahead and loaded an image called CloudFront 10-year. Just this past week, we had celebrated CloudFront's 10-year anniversary, and we have commemorative stickers and pins at our booth if you'd like to go and visit and talk more about CloudFront. So in this image, you can see that I'm actually accessing it through a distribution here that's going through CloudFront. This image is hosted in an S3 bucket. So if I go to this bucket, you can see the image is located right here. If I were to try and access this image directly, or again, not through the front door being CloudFront, I will actually get an access denied response. So the response comes back, blocking the request. If I look at the policy of that bucket, you'll see why. So if I go to the permissions of this bucket and look at the bucket policy, you'll see here that it says I'm only going to allow something with this policy ending in CXP to get objects from this origin, being my S3 bucket. So now let's look at how that looks on CloudFront's side. If I go to the CloudFront distribution that I was using as my endpoint, and I go into my origin, here's my origin that I had that image hosted. And if I go over here, you can see again, CXP is the same origin access identity that was listed in my S3 bucket policy. What this again means is that only things coming through CloudFront will be able to access that bucket. Now, if you have an existing bucket, it's very easy to go ahead and get this set up. You would just again come to the origins and click edit. And here you would say create a new identity, or actually first you would say restrict bucket access yes, create a new identity, and then say yes, update my bucket policy, and it will go ahead and automatically update that in S3, thus restricting access only through CloudFront. Now, if you have a new distribution that you are wanting to create, it's again just as simple. So you just go ahead and get started. You choose an S3 bucket. You would say restrict access, yes, create a new identity, yes, update my policy, and then when you create your distribution, it's all set up for you, ready to go. All right, so now let's talk about how you would do this also for your custom origins and how you would automate to make sure that the IP addresses within that custom security policy are always up to date. And you're going to use this by doing a few different things. We publish our IP space ranges to the internet in a JSON file. What we can do is we send out an SNS notification anytime that gets changed, so you can create a Lambda function that is ingesting that SNS notification. And through an IAM policy that allows that Lambda function to go ahead and access your security group in EC2, it will then update that policy with the new IP ranges as they may be added, again, as CloudFront continues to grow. We have a blog that details this step by step, And again, webinars that show you how this can be done as well. And with that, we've now added our first layer of perimeter protection by restricting all access to your application through a singular front door, that front door being Amazon CloudFront. I'm now going to hand the session over to Ritwik to talk more about how we can add the next layers of perimeter protection to applications running on AWS.
Thanks, Woodrow. Cool. All right, so we've added a secure content delivery layer. However, our web application is still susceptible to attacks from bot traffic, which might be trying to troll your prices, or right up till trying to use credential stuffing attacks to take over your end user accounts. Or you're still susceptible to attacks that are trying to take advantage of application vulnerabilities, such as SQL injection attacks, cross-site scripting, or trying to take advantage of things like Apache vulnerabilities or Nginx vulnerabilities. And that's where a firewall comes into the picture. And in this case, it'll be a web application firewall. So when you're thinking about choosing a web application firewall, there are a few key tenets that we talk about when you're thinking about a WAF. The first is it should be very easy to set up foundational security that takes care of common exploits, while also having a powerful rule engine that you can create custom rules that are specific to your application. Then you should also be able to have a transparent WAF that helps you look at all the requests that are coming in, as well as the actions taken by the rules that you've created. As that can then inform your automations that creates and updates your security for an ever-changing landscape. So at AWS, we created AWS WAF that helps you do all of these things. So when you wanted to create your simple foundational security, customers like eVitamins used our easy-to-use CloudFormation templates that help them set up their basic protections quickly. And a lot of customers started using rule groups from our AWS Marketplace, which we launched about a year ago. These managed rules are created and updated by security experts such as F5 and Fortinet. They're completely pay-as-you-go, so you do not have to worry about a lock-in or a long-term commitment to them. And you can easily subscribe to any of these rule groups through the AWS Marketplace and put them directly into your web access control list. And we constantly work with all of our partners to keep increasing the breadth of securities that are available based on your feedback to us. So once you've built that foundational security, you can then use our powerful rule engine to create your own custom securities. To do this, you start off with a rule. A rule will have a number of different rule conditions, which can be anything ranging from a regex rule to a query string to a simple IP match. And then you can combine them up with logical operators and put each one of these rules into a container that is the web access control list in a defined hierarchy that you can customize as you see fit. Each of these rules can have their own individual actions that you want the web ACL to take place, or you can have a default action that takes place if a request does not satisfy any of these rules. So with this, you can then go ahead and make sure that you are analyzing your security, and customers want to do this for a number of different use cases. So for example, you could want to look at just being notified when there is a sudden spike or a drop in a particular type of requests. That's where our CloudWatch metrics come into the picture, which gives you actual data on everything that's coming through and what our action was on them. Secondly, you could want to try and triage events and quickly test out rules that you're creating. And there you'd use what we have is the sampled web requests. That gives you a sampling of requests with all the detailed logs of them. So you get to see all of the requests, and you can filter them by the rules that you've created. And based on your feedback, a couple of months ago, we also launched full logs, which builds on top of the sample requests and actually gives you full, all of the logs that are there with detailed IDs of the rule IDs as well as the request headers. And it really helps to do things like security analytics, monitoring, automation, as well as auditing for compliance. And we built full logs based on your feedback, and we built it to be extremely flexible. All of the rules are actually streamed in JSON format through Amazon Data Firehose to a destination of your choice. To those who are familiar with Amazon Data Firehose will know that this could range from an S3 bucket directly into Redshift cluster. You could be sending it into Elasticsearch or directly into your Splunk. A second use case customers really appreciate this for is for compliance and auditing, where because you're getting all of the rules with the full request headers as well as the rule IDs that matched against them. Now you can choose to also redact some of those request headers that you feel are sensitive. So these could be cookies, or if you're transmitting credit card information or username and password information that you don't want to log. And finally, customers really appreciate the fact that we worked with third parties so that they could very easily centralize and analyze logs from WAF and other services, while using things like pre-built dashboards that these services have already built, as well as intelligence that they've already built and your security teams are used to. Okay? For a simple step-by-step guide on how you can use full logs, I'd encourage you to check out a webinar, which is the Enhanced Security Analytics using AWS Full Logging. Right. So after this, we started analyzing this, but a lot of customers then extend this out to start to automate for dynamic security. That means that you want to be able to do things like block bots that you identify in the future, or connect this up with other findings that you have across AWS. That's where software automation for the firewall comes into place, and there are two ways that you can do this with AWS WAF. The first, as I'm sure a lot of you will be familiar with, is using Lambda-based automations. And you're able to do this because you have full-featured APIs for WAF and fast rule updates. That means any changes that you're making to a rule gets globally propagated within seconds, right? And you have customers like Pokemon who have built networks that do things like bad watch, scanner, and known attacker networks for this, as well as customers who appreciate that they can integrate with findings on other services like GuardDuty. And you can check out the blogs and webinars for this. I do encourage you, if you haven't, to check out the talk by Pokemon on how they're using WAF to block bots in their strategy. Finally, based on a lot of feedback that we started getting, we also came out with config-based automations that customers could do. And in April, we launched AWS Firewall Manager. Now, Firewall Manager helps you simplify rules across accounts as well as applications with security policies. And while you can customize each of those policies to a resource type with a tag, as well as include or exclude certain accounts for it. So think of it as if you want to set up a PCI compliance policy that has a certain set of rules that your central security teams wants all of the dev accounts to always have on application load balancers with the tag PCI, you can do this with Firewall Manager. And it helps customers ensure compliance with things like this for mandatory rules across the organization, while it also helps to enable rapid response when it comes to internet attacks. So when you're thinking about identifying bad bots on one application, with Firewall Manager, you can ensure that identified bad bot is also automatically starts to get blocked on another application. And I'm going to go to a demonstration that helps you visualize that use case in just a sec for that. So what we're going to do here today is we're going to have two different applications, a part of the same AWS organization on two different accounts. A bad bot that's identified on one application will start to get blocked on the other applications immediately. I'm using a honeypot network for this. The automation, you can see the step-by-step guide by searching for AWS WAF security automations. Honeypot, to give you a sense, is actually a hidden link within an application, within a website that a human user cannot see, but a bad bot will not respect that. While they're crawling through it, and they will actually try and access that link, and that's when you know that IP is definitely a bad bot, right? So let me start off by showing you what my organization looks like. So in this case, I have an AWS organization which has 3 accounts. The first one is the org root. The second is what I've actually gone ahead and designated as my FMS admin. Right? So this is important because you could think of this as your AWS organization can be headed by your CIO, but your security team that's doing the compliance can have a separate account on it. Right? So I have two applications. This is the first one. This is the one that's managed by the FMS admin. And I'll show you the second one. This is the second application that I have. Now, just for everyone's just so that we all know, I'm actually trying to access this through this IP address. Here, what I'm going to try and do is start to access this honeypot link that was there. And you can see it's been blocked. My IP was recognized. And while we're talking through this, if I start to access the second application on it, you can see that I'm already forbidden on it. So without any changes on the second one, I've immediately built this honeypot that works across my organization. To give you a sense of what that looks like, let me quickly go into the console and show you that I've actually created a policy called the reinvent honeypot demo, which will give me some trouble. So while I try to log back in, you can look at the same screen that I showed you earlier. All right. So I'm going to go ahead and show you the security policy that I have. So in this US East region, I've actually created a rule group which I put into a security policy called the reinvent honeypot demo. This is the rule group that I created. You can see that the policy automatically found all of the accounts within my organization. It shows you there are two accounts that it was able to apply that policy to, and one was non-compliant because it's actually missing AWS config. The third account has not had config enabled on it, which is why you can't see it. Now, the rule group that I created to be put into this has this bad bot rule that I've created, which actually now has the IP address that is populated within it, right? And if I go back, I can see that the web ACL that's connected to my application for the second application already has the rule group that I created that gets applied in this case. Whenever you create a security policy, it will go into all of your organization accounts and create web ACLs and attach them to the resources as requested. You can identify them with this fantastically long web ACL ID here. All right. So with that, we can then say that we've added the firewall layer on top of the application that we were working with. But however, even though we are looking at all the requests, we're filtering them, a lot of times malicious actors will be okay with being denied access, but being able to consume your resources to a level that you're not able to serve your legitimate users. Okay, that's where distributed denial of service attack comes in. That's where you need DDoS protection on it, right? And when you're thinking about DDoS protection, there are 4 key tenets that we again encourage you to think about. DDoS protection provider to us is a good one if it helps you set up your DDoS protection with minimal architectural changes. So you're not thinking about making changes on your architecture because you want DDoS protection. You can go ahead and build your own architecture for your business. Secondly, it adds a minimal operational load for you to identify and mitigate against attacks, while also giving you visibility in everything that it's detecting and mitigating against, right? And the last tenet that we feel is very important is the fact that a malicious actor shouldn't be able to make your bill as an attack vector against you. So even if you were still available, but you had to scale out, that will lead to an increased bill for you for the same amount of traffic that you're serving, for the same amount of legitimate traffic that you're serving. So you're not adding a lot of value with there. That's where we feel that protection against the economic vector is also important. And at AWS, we've built for this with Shield Standard and Advanced, which, using these tenets, we've helped customers like Netflix who are not just all in on AWS, but are all in on Shield Advanced, right? And we've helped them with things like setting up your DDoS protection by Shield Standard or Advanced. With Shield Standard, you actually get built-in DDoS protection for everyone. That means that just by being on AWS, you are using Shield Standard. We built Shield Standard to make sure that you don't need to worry about basic DDoS protection, but you can also go ahead and upgrade that protection with a simple point and protect wizard. So you can choose your high risk, your highly important prod resources to protect where you feel you need better DDoS protection on. That's why you have customers like Pearson come in, quickly protect all of their resources, and completely get rid of availability impacts that they might have. And this makes sure that we are looking at all of the traffic and make sure that we're actually detecting and mitigating the thousands of DDoS attacks that are coming and hitting our customers on AWS, right? Next, once you've started to protect it, with Shield Standard and Advanced, we want to make sure that there is minimal operational load on you to think about DDoS, right? With Shield Standard, you actually get automatic protection that's optimized across all AWS customers, right? What does this mean? This means that we're using heuristics-based anomaly detections to baseline traffic across AWS and then to look for anomalies that we don't expect on a CloudFront distribution or on a regional service, no matter what region that you're in. And then to mitigate it with a proprietary packet filtering stacks that we call Blackwatch, that uses suspicion-based scoring to actually drop malformed packet on the network and transport layer. And this enables the fact that being on AWS, you actually get automatic defense against most common network and transport layer attacks for any AWS resource in any region. And if you're using a global service like CloudFront, you actually get comprehensive protection against all known network and transport layer attacks. And we're able to do this when we looked at the numbers. It was like 99.9% of all attacks, or all network and transport layer attacks on these global resources are detected and mitigated in under a minute, right? But a lot of times, customers wanted a little bit more. They wanted to go one step ahead. They wanted enhanced protection that's actually baselined to their traffic. And that's why we went a step ahead, and we actually tweaked both our detection as well as our mitigation for this. So on the detection side, you get enhanced layer 3 and 4 attack detection that's actually baselined to your traffic, to the resources that you are protecting. And then we're using the same Blackwatch stacks with pre-configured mitigation templates that are scoped to the resource type that you've chosen, as well as using advanced mitigations like SYN throttling on it, right? And if you're using a regional service, you can actually define pre-configured templates for this layer 3 and 4 protection on it, right? With Shield Advanced, we actually go one step ahead, over and above network and transport layer attacks, and look for layer 7 web application attack anomalies as well, right? But we know that attacks and DDoS scenarios are always changing. There will always be edge cases which which might be new vectors that come out in the market, or it might just be a new way of attacking your particular resource. And that's why we actually give you 24/7 access to the DDoS response team, which takes care of manual mitigation, manual triaging and mitigation on your behalf as a Shield Advanced customer. They are automatically engaged when there's a network congesting layer 3 and 4 attack that's affecting a lot of customers. Or you can, as a Shield Advanced customer, you can go ahead and engage them using through our AWS support, or using what we've put together as a Lambda script, which is a Shield Engagement Lambda. And that's where you have customers like Dow Jones and the Wall Street Journal who've made the DDoS response team, Shield Advanced, a core part of their security. They've actually connected the Shield Engagement Lambda with an IoT button that they keep in their operations center. And whenever they press that button, our on-call on the DDoS response team gets a page. It automatically creates a chime bridge as well as cuts a support ticket so that we can get on call with you immediately, right? And that's helped us do things like protect very significant attacks, like we had the 1.4 terabits memcached attacks that Woodrow was mentioning. As well as just this last month, we had a web application that was hit with 20 million requests per second, and that was automatically mitigated because they were on CloudFront and Shield Advanced. So once we've gone ahead and detected and protected your application against DDoS, with Shield Advanced, you also can get visibility into that. So we emit a number of CloudWatch metrics which tell you if there was a DDoS detected, what are the major vectors on it, and what was the size of the attacks attacks that your resource is seeing. Then you're also getting detailed attack diagnostics, which tells you things like what are the top IPs during the time of the attack, what are the top ASNs, your top geos. So gives you an extra input to say that, okay, I'm seeing traffic from a region that I never expect traffic from. I shouldn't wait for DDoS to come from those regions. I should go back and put a WAF rule in place that automatically drops all of the traffic from that region, right? You also get access to the global threat environment dashboard, which is an anonymized view of what we at AWS are seeing. So you get a near real-time view, a dashboard that gives you an idea of how many attacks we saw across AWS, across Shield Standard and Advanced, which were the regions that we saw those attacks on, what were the major vectors, what was the size of those vectors, and most importantly, what is the threat level? Are we seeing this as a normal threat level, or is this something that we feel that you should know about? Is this high threat level or not, right? And finally, when we talk about protection against economic vectors, we want to make sure that you're protected all around, not just on the network and transport layer attacks. If you are dropping traffic even on the layer 7, we want to make sure you can do that with peace of mind. And that's why if you're protecting a resource with a Shield Advanced, you get AWS WAF at no additional cost. You also get Firewall Manager at no additional cost on it. Finally, we give you cost protection for scaling. That means if you got a resource that was protected, and there is a DDoS attack, and you had to scale in order to remain available, then we're gonna help you out. We're gonna give you credits for the amount of scaling that you're doing, right? So that's to give you an idea of how we feel and how we've gone ahead and created both Shield Standard and Advanced with our customers' needs in mind, and based on everyone's feedback that came in. And it ends up with us adding the extra final layer of DDoS protection. Now, looking at this diagram, some of you might have a question on what if a simple web application is not what you're looking to protect, right? So let's talk about a few common custom applications that we've heard a lot from customers coming in, and how you can change that same layered technique to be protecting them in the same way. So the first case that we want to talk about is what if you have a serverless architecture or APIs that you would like to protect. In that case, your secure content delivery layer, we encourage should be an Amazon API gateway, because it helps you create a unified API front end, but it also helps you with things like authentication, authorizing requests, and throttling, metering, and monetizing API requests usage by third-party developers. A few weeks ago, we actually also announced AWS WAF for API Gateway. So you can do the same WAF strategy for protecting your API Gateway endpoints as well, with all the goodness of your full-featured APIs and the powerful rule engine on it. And we've worked with partners to be making sure that we're also creating or helping or having them create API-specific managed rules on the marketplace as well. And you're still protected with AWS Shield Standard because, as I mentioned, all your resources on any region automatically get AWS Shield Standard. A second use case that we've heard a lot of customers talk about is, what if I have TCP traffic that's non-HTTP or HTTPS, right? Here, we actually suggest that you're using a network load balancer, which is a fast-scaling, transparent load balancer that's actually architected for performance and availability. And if you've heard the news yesterday, then we'd further suggest you add on top of this the AWS Global Accelerator that takes out your load balancing all out to the edge and helps you with global load balancing across regions with anycast routing and fine-grained controls. And I also want to announce that on day one, since yesterday, you can protect your AWS Global Load Balancer with Shield Advanced. So you're getting all of the goodness for your upgraded DDoS protection, but you're also getting granular detection thresholds. That's based on background architecture. That means we take the heavy lifting of going back and looking behind your network load balancer, looking at what is the architectural choices, what is the size of the instances that you're using, and then tweaking what does a DDoS mean for you accordingly. You can then obviously work with us, either use the pre-configured mitigations that are automatically turned on, or we can help you create customized mitigation templates as well. And finally, we push when it comes to network regional services, like network load balancer. We take network ACLs and push them out to the border so that they're not taking up resources on your VPC, but we're dropping traffic as far from you as possible. Another very interesting use case a lot of customers talked about was, what if I'm running UDP-based games, and a number of these gaming customers actually have public-facing EC2 instances. Now with Global Load Balancer, you can protect those public-facing EC2 instances by using the elastic IPs as the target for the Global Load Balancer itself. And again, you're still able to protect with Shield Advanced for upgraded DDoS protection. If you do not wish to use the Global Accelerator, last year we announced Shield Advanced for elastic IPs, which directly on the EC2 instances or the network load balancer as well. With that, let me just summarize to say that we started off with a basic AWS application, added a bunch of layers on top of it, and ended up with a multi-layered secured application that protects you again, that makes sure that you have a secure content delivery layer, protects you against common as well as your specific custom exploits, and then also protects you against DDoS on all of this. Thank you for coming out tonight. Thank you for coming out to reInvent. Just to remind you, please complete the session survey in the mobile app. It's extremely useful to us to make sure that we're giving you the right content in the right way. The deck, as Woodrow mentioned, will be available on SlideShare, and the recording will be available on YouTube. If you're interested in these topics to deep dive into them, here are some of the breakouts that I absolutely suggest. You can check out how to secure your site using CDN security features. You can also go to the Pokemon session that I mentioned, which is tomorrow, where Pokemon talks about how they built their own automations on WAF to protect themselves against bots. And then you can also go to the talk by Rovio, which talks about how they're using CloudFront for secure API acceleration. Thank you all. We'll stick around for a few minutes to take any questions if you like.